we are going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss the chemical methods, how we can synthesize the nanomaterials. So, here there are few methods. So, already we have discussed chemical methods. So, already these are the methods we have already discussed. So, today we will discuss the sol-gel methods, hydrothermal methods, sonochemical methods and microwave synthesis. So, these are the methods we can use also to synthesis nanomaterials. So, first we will discuss sol-gel methods. So, these sol-gel methods, that was name you can see sol-gels, means initially means there are two components, one is solution, another is gel formations. So, here the starting materials means if you want to prepare for a particular metals nanoparticles. So, then or nano film formations. So, then we can take that precursor of that materials and then we can make a solutions, and then solutions would be converted into gels, and then with that gels we can forms different type of materials. So, that would be in the nano range. Okay. So, that this method is very old method. So, that was started from 1845 and since then that method still are useful. So, and used for various material synthesis. Okay. So, in these methods actually highly pure materials or nanomaterials that we can synthesize. There are other methods also, CVD or metal organic vapors, that is these are the method also we can use for the material synthesis, but compared to those methods or these methods is very useful to prepare a highly pure materials we can synthesize. So, in this particular methods means there are many methods I said. So, this method also we can choose, this method is very simple. Okay. So, therefore, we can choose this particular methods to prepare our nanomaterials. In this method some various type of unique materials means aerogels, zeolites or other porous solids by organic inorganic hybridizations. So, we can prepare using this particular methods. Okay. So, various metals, metal oxide, metal rods that we can prepare using this synthesis. Okay. So, already I have said that this method is very easy to prepare any nanomaterials using these methods, and also highly pure materials we can synthesize, and well controls means the concentrations we can control, and using that precursor concentrations changing we can change the concentration at size also we can controls, and these methods usually requires very low temperature. Therefore, energy consumption is very low for this particular method, sol-gel methods, and also less pollutions also that would be generated means after reactions that finals byproducts formations, that is also not that much toxic. So, in solutions I said a solutions of a particular precursors that would forms, that is a subclass of colloids, means here one solvents we can take, there we can put precursors metal ions salts that would be used make a solutions. Okay. So, once solutions would be evaporated low temperature. So, then it would be converted into gels. This type of structures it may forms, that is inside of this there is some liquids that may be polymeric type of compounds that would be forms in the form of gels. So, that once that way that nanomaterials or ionic metal ions that would be distributed. So, once that would be heated up. So, then polymeric compounds that is organic that would be evaporated out or maybe decomposed, oxidized, and then the skeletons will be remain there. So, that is in the form of powders or thin films or monolithic solids, that is metal oxide, ceramic oxides. So, depending upon the things we are evaporating or removing that liquid or solvent from that gel, that particular structure would forms. So, initially I said the initial or beginning stage is solutions formations. So, here this is the metal ions that is distributed in any particular solvents. So, after that gel formations is there. So, gels, this is the metal ions and inside polymeric containing liquid is there. Once this gel should be removed by heating up. So, then skeletons of metal oxide remains or left over there. So, that way we can develop that particular materials depending our application. So, we can synthesize films, fibers, uniform particles, metal oxides or any powder or any monolithic type of materials that we can synthesize. So, here the starting material precursors we can use any metal chloride, metal nitrates depending upon our interest. So, here the reactions parameters that we have to control the size of that nanomaterials. Number one is precursor concentration I said. So, depending upon lower to higher concentrations we can change the gel formations or gel the material concentrations when solutions and gel formations should be there. Then calcination temperature also parameters that we can control. If we heat it up at low temperatures, so nanomaterials then would be in the dispersed forms. So, when it is calcined at high temperatures, so there is possibility of agglomerations and bigger size or larger size of particle formations is there. Also, each of the solutions we have considered for the preparation of the gel. So, controlling the pH depending upon acidic or pH signatures. So, we can control the precipitations or structures of that particular gel. So, here once we convert that solutions into gel, so then that gel can be used for preparations I said coating or films. So, if we make a coat means thin films type of coats and then if we calcine that, then polymeric compounds or gel or liquid formations is there. So, liquid gels I said that gel should be removed and then the ceramic oxide or ceramic films formation should be there, that may be in nano range distribution of that films. If we want to make a fibers, whatever the gel formations is there, that gel will be used in spinning methods. So, that technology is there. So, with that help of spinning, so we can prepare sol in the form of fibers and then by calcination different type of fibers we can prepare, or we can supercritical extractions means once the gel formations is there, that inside polymeric gels that we can remove by supercritical extractions, then that would be aerosols, or else we can by normal conventional evaporations zero gel formations is there, and after that if we dry or heat up, so then metal oxides that would forms, or else from that solution directly also we can make powders. This type of means depending upon our applications or methods available, we can prepare either it is films, fibers or particles in the form of metal oxides or monolithic type of structures also we can develop by using these sol-gel methods. For a particular metal oxides we can prepare, or materials nanomaterials we can prepare. So, next using these sol-gel techniques, so titanium nanoparticles that can be synthesized, that we will discuss. So, these materials usually use photocatalytic reactions. So, here we have to start it with a precursor of chloride of titanium, make a solutions, and another beakers we can consider. So, we can make another solutions by considering acidic acid in waters we can mix, and then both will be mixed up at low temperatures and then heating up with stirring. Gradually or slowly we can remove that solvents that was taken, here waters, here ethanol was taken. So, gradually remove and then slowly at low temperature. So, then one gel formation should be there, and once the gel formation is there, so gradually that would be heated up, calcined at high temperatures, and then we can get this TiO2 nanomaterials. So, these are the applications where these nanomaterials can be used for the NOx reductions and productions of hydrogens, photochemicals reactions, wastewater treatments, photo degradations of pollutants or coated surface. Many places are there where this TiO2 materials that can be used, or also sun screens, paints, cosmetics. There are numerous or many applications are there where it can be used. Next is the sol-gel synthesis. So, this is SiO2 silicon dioxide that nanoparticles we can prepare by using this. So, here one silica precursors we have to consider, and acetic acid, ethanol, methanols we can consider. So, then it would means mix them up, and then after stirring we can get this type of means we have to maintain some temperatures and acidic conditions. So, then ester formations is there by reacting by considering these reactions, and these precursors means these precursors we have to use for silica tetraethyl orthosilicates, and then both will be mixed up, and then if we make a gel formations and then gel will be heated up 500 degree centigrades, we can calcines, then silica nanoparticles we can make by these methods. Okay. So, these two different silicon dioxides and titanium dioxides, how we can prepare by sol-gel methods, that we have discussed. Next we will discuss hydrothermal methods. So, in hydrothermal methods usually we can use high pressure reactors. So, that is autoclaves we can say. So, it is a sealed vessels. So, we can use for the preparations of the nanomaterials. So, in this case also by using this particular hydrothermal synthesis, here we can prepare nanowires, nanorods, nanosheets, nanospheres. So, here depending upon means when that precursors that would be taken in a sealed vessels. So, here different type of solvents we can use. The solvent depending upon that solvents we can say it is solvothermals, include glycothermals, alkothermals, ammonothermals. So, depending upon or based on different solvents, these techniques also categorized or named like this. Or when these means sealed vessels or autoclave was taken for preparation of these materials, here conventional heatings we can use, or apart from that microwave heating also we can use to get very fast heating. So, with the hydrothermals, microwaves also we can use to heating up that solutions to prepare that nanomaterials. So, in this type of particular methods, hydrothermal methods, so here high temperatures we can use and high pressures I said. So, 100 bars, so maximum 100 bars, so pressure, so 1 to 100 bars or more than that also we can use for the synthesis of these nanomaterials in autoclaves. Okay, this is very old techniques actually. So, mostly that is used in geologists by later that also adapters and used for the preparations of different type of nanomaterials. So, here on schematic diagram or figure is showing here. So, this is autoclaves. So, you can see. So, that can be used by using a heaters at high pressures can be developed. So, this is conventional method. So, this is autoclave. So, here solutions we can take and then it would be sealed, and then we can heat it up 250 300 degrees centigrades, and for a longer period of times maybe 1 day, 2 days, 3 days, 4 days, 5 days we can keep it there, and then reactions will be take place inside of that vessels and we can generate nanomaterials. So, that is conventional methods. So, apart from that microwaves I said. So, heatings would be with the help of microwave irradiations. So, then in this case polymeric body of these autoclaves we have to use, and in this case metal body we can SS stainless steels we can use, steel body we can use to sustain high pressures, and in polymeric body of these autoclaves. So, here we can use microwave irradiations for that particular vessels. And next is the sonochemicals methods. So, in sonochemicals means ultrasounds that we can use. So, instead of conventional thermal heatings or microwave heatings, ultrasounds that can be used for the cavitations generations. Cavitations means some bubbles formations, that bubbles will form and then that would be during that process by using ultrasound waves. Okay. And by that way we can means make that synthesis process different. By that way we can synthesis nanomaterials. Okay. So, whence we use ultrasounds that would enhance that chemicals reactions, means in a particular vessels we can consider the precursors and solutions solvents, homogeneous solutions formations is there. Here we can put ultrasound irradiation. So, then that would the solutions would generate bubble formations would be there very short period of times by, and that due to the means here cavitations will forms, and with the cavitations bubble formations will be there, bubbles will be collapsed within very short period of times, and then as a result high temperature, extremely high temperatures and pressures will be developed in that particular locations or in that particular inside of the reactors when that bubbles will be collapsed. Okay. So, therefore, high local temperature and pressures will be developed when that ultrasounds would be used for nanomaterial synthesis to control the reactions. So, here I said in that cavitations process means how that methods means sonochemicals or ultrasounds that would when it is passed over that solutions, there is bubble formations is there, bubble growth, and then bubbles will be collapsed in liquid medium. So, whence that bubbles will be collapsed, I said extremely high temperatures and high pressures should be developed. So, when bubbles will be collapsed, so and hot spots will be developed. So, at this particular temperature and pressures, various type of radicals may forms that actually initiate the reaction. So, in these particulars methods, various type of radicals, highly reactive radicals will forms that will initiate the reactions. So, therefore, these radicals are in these ultrasound waves we can use. So, that enhance the mass transport, alter the morphology and surface properties of that materials that we are going to synthesize. Also, depending upon the nature of ultrasounds, we can also do the exfoliations, that is method of separations means layer separations, that also we can do by using these techniques. So, here sonochemicals equipments that are different types or various types are available. So, here cleaning bath sonochemical equipments. So, here it is suitable for mild sonications or homogeneous reactions. So, in that case we can use cleaning bath sonochemicals equipments for synthesis of nanomaterials, or probe types also we can use, that is prefer for means prefer for localized high energy reactions. So, in that case a direct energy transfer into the reactions mixtures using that ultrasonic horns that would be used for synthesis of nanomaterials. Then horn reactors, that is another types of sonochemical equipments that can be used means to enhance that mass transport and accelerate the reactions kinetics. So, when mass transfer means reactions will take place for the nanomaterials formations that suitable for industrial scale or large scale applications, and another one is the longitudinal reactors that also prefer for large scale productions. So, I said in ultrasound device or sonochemical equipments, there are ultrasounds that is used as a transducer that converts mechanical and electrical energy into ultrasounds. So, that ultrasounds intensity may be high frequency or low frequency. If it is high frequency, that is used for the reactions, and it is low frequency, then that can be used for exfoliations, that is also another type of nanoflex formations. So, in that type of synthesis there we can use low frequency, but in case of the reactions, when reactions is important and nanomaterials formations is important, so then high frequency we can use. So, here is how that ultrasound induced cavitations work. So, here in solutions is there where ultrasound waves would be there. So, bubble formations would be there, then compressions and rarefactions is there. So, bubble growth formations is there, and then that bubbles will be collapsed, and certainly high temperatures and pressures will be developed within that spots, and that would help to further reactions, chemical reactions for nanomaterials synthesis. Here different type of instrumental scheme is showing here. So, cleaning bath, probe systems, horn reactors, and longitudinal horn reactors. So, that is showing these 4 different type of instruments that is available for preparations of nanomaterials by using sonochemicals methods. So, in these methods we can prepare few examples I am showing. So, here manganese dioxide nanoparticles that we can synthesis. Here for manganese we can use the precursors, that is potassium permanganate and PEG, polyethylene glycols, that we can take in these reactors, and after that probes or tips that would be here placed, and then ultrasound cavitations would be there, and with that different type of nanomaterials we can prepare, and that would be calcines, dryings, cleanings, we can get very small diameters nanomaterials that we can synthesis. Apart from that, there are some others also materials we can synthesize using this particular sonochemicals methods or sonochemicals routes. So, activated carbon, silica, organometallics, MOFs, COPs, everything we can prepare, many materials we can prepare. Okay, so, there are some other materials also that we can prepare by using, here few examples are there. So, means using this microwave synthesis, So that also is important. So here the microwave, that also we can use for the nanomaterial synthesis. So these are the various nanomaterials: zinc oxide, manganese oxide or iron oxides, cobalt, magnesium doped zinc oxide nanopowder. That also we can prepare. This is another method of synthesis, microwave synthesis. So here we can use a particular reactors. There we can put our starting materials or precursor solutions, and then with the help of microwave heating, so we can develop that particular temperatures that would help for that particular reactions. And once a reactions is over, then we can do others, means filtrations, separations. That way you can prepare different type of materials. So here microwave assisted zinc oxide nanostructures formations. Here these are the precursors, zinc precursors, PEG and base and other solvent that was taken here, and then microwave irradiations was considered for the synthesis of the nanomaterials. Here water was used as a solvent at 140 degrees centigrade for 60 minutes. This type of nanomaterials we can form. So when ethanol was used as a solvent, these nanomaterials we can prepare. Okay. So when a certain percentage of ethanol and waters, both solvents at different ratio we have used at 160 degrees centigrade for 90 minutes. So then nanorod type of zinc oxides that was synthesized by using same microwave irradiations by changing different solvents. So we can spherical to nanorods we can prepare using the same materials. So here's manganese oxide nanorods, that also we can synthesized by using these are the precursors that was taken and microwave irradiations was used, and then we heated up for 90 minutes 120 degrees centigrade, and then after filtrations this type of manganese oxide nanorods that we can synthesize. Okay, so capped, uncapped also we can, metal oxides also we can synthesized. So initially metal oxides was taken CMO3 and ethylene glycols, then ultrasounds wave was passed through this solvent solutions, and then we can oleic acid as a capping agent that we can use, or hydrogen hydrate that is as a reducing agent that also we can use. Then this metal oxide would be reduced partially and we can get this type of metal oxides. So by reductions, so if we use oleic acid as a capping agent, then cap MO2 will forms. If we don't use oleic acid, then it would be uncapped molybdenum dioxide that we can synthesize. So this way means microwave assisted synthesis we can do preparation of molybdenum oxides. Similarly iron oxide also we can prepare by using microwave irradiations in solvents, that particular solutions, and by that way nanoparticles or nano range metal oxides or cobalt or magnesium doped zinc oxide nanomaterials and nanopowders, that also we can synthesize by using this microwave irradiations method. So here similarly, depending upon our study of interest, we can use that particular precursors, base solutions, and then we can do precipitations, and then we can put it in a microwave, and then in a aluminum crucible we have put it here, and then microwave irradiations will be passed over that precipitates, and then if we separate out that precipitates, and then if we heat it up at 600 degrees centigrade, this is muffle furnace. So here if we heat it up in presence of air at 600 degrees centigrade for 1 or 2 hours, so then we can get cobalt or AMG doped zinc oxide nanoparticles. So we can forms. So thank you. So today is up to this. So we have studied so many method of synthesis by chemical routes to prepare nanomaterials. Thank you.